Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our study guide in preparation for our Chapter 4 test number 2, which we will be taking next. If you're doing this study guide, if you're reviewing the answers, you're ready to take this test. So the first part of the test is going to be on combining like terms. And so here are a couple of examples to help illustrate how we do what we do and why we do what we do. So if we take this expression that has three terms, 3x plus 5x plus 7x, you're literally saying you got three x's. We don't know what the value of x is, but we know we've got three of them. We're going to add another 5x's to that, and then another 7x's to what we already had. So you can write this as a spread out expression, or you can put them all together. You're adding the 3x's and the 5x's to make a pile of 8x's here, and then you slide these 7x's over with the 8x's to give you a grand total of 15x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So in essence, what we do here is when we are combining like terms, we are adding together the terms that have the very same variable raised to the same exponent. And these are all x's to the first power. So really what we're going to do is we're going to add, oh no, not with that though. We're going to add together the, let me get that a little thinner. We're going to add together each of our coefficients. Those are the number parts of these terms. So you're going to add the 3, the 5, and the 7. And once you add those together, that total sum is going to be what you multiply times x. So 3 and 7 make 10, and 10 and 5 make 15. So the answer to this is 15x. Okay. If you are combining like terms for a variable expression that has two different types of terms, like here we've got our constant terms are the 12 ones here and the 5 ones there. And here you got your variable term, your x terms here and your x terms there. So what we would want to do is we would want to maneuver these around using commutative property and cluster all of our x's together and all of our ones together. So all of the x's, you end up with the 3 plus the 7 equals 10 x's, right? And then you've got the 12 plus the 5. Okay, so we're showing how you use commutative property down here. And then when you combine like terms, you just add the coefficients together. So you end up with the answer of 10 total x's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and a total of 17 ones. There's 12, 13, 14, 15, 16, 17, and that is the answer that you declare. Now, I want to make something clear to you. If, did I just erase a bunch of answers? No good. Okay, if you were to say parentheses around these two terms and parentheses around those two terms, that's just telling us how these were grouped to begin with. So this is saying you've got a group of 3 x's and 12 ones, and here is a group of 7 x's and 5 ones. Let's put them all together. You don't worry about the parentheses being here, because associative property allows us, when all we're doing is adding terms together, allows us to regroup these any way that we want. So here we're going to use commutative property and rearrange the order of those two terms, because when you rearrange the order of terms, it does not change their sum. And then we'll group these guys together, group them together, and then combine them accordingly. So when we see problems like we see here 1 through 8, where some of these have parentheses, you can just ignore the parentheses entirely for most of these problems. Where it becomes problematic is here and here. And I promise you, I'm not going to put problems like this into the chapter test because we have not spent a lot of time working on this. But it would be interesting to see. Actually, there is kind of a problem that's similar to this, but maybe that was on your assessment on Friday. I think it was the one with Hermione and Ron, or was it the one with, I can't remember. At any rate, you're not going to have any procedural problems like this where you have to remember what I'm going to tell you to do right now. So let's focus on problems 1, 2, and 3 to begin with. If you had a pile of 2x squareds in this grouping and a pile of 4x squareds in that grouping, when you combine those two piles, you get 6x squareds. If you have a pile of 6x's here and a pile of 2x's there, when you combine them, they make 8x's. And when you have a pile of 10 ones here and 3 ones there, you combine them to make a total of 13 ones. Okay? So basically just coordinate for problems 1, 2, and 3. Coordinate all the x terms, all the x squared terms, and the constant terms, or the single unit tiles, and put them all together. That should be pretty straightforward. Now, I am going to have to show you what's going on here. This is kind of like a problem where we said, all right, let's start off with you got 4x squareds plus 6x's plus 5 1s on your desk. And someone comes by and knocks off 3x squareds plus 2x's plus 4. Well, this is a situation where you're going to have to use KFC to change all of these to their opposites. It's essentially distributive property where you're multiplying every term inside the parentheses times -1. You're taking the opposite of them. So this is like you're saying, I'm going to take away 3x squareds from the 4x squareds, and that's going to give you 1x squared. And then I'm going to take away 2x squareds from 6x, so we're going to change that to plus negative, and then that's going to subtract to make 4x's, and then you're going to take away 4 from the 5, so it becomes -4, and that gives you a +1. So this is a pile of tiles, and these are the tiles that you're taking away. Everything that's inside the parentheses is getting taken away from there, okay? Same thing applies. Let me go ahead and get rid of everything there. The same thing would apply to this problem, where if you start off with 3x squared, you're going to take away a 1x squared, and that's going to give you 2x squareds. If you started with -7x's, then you have to take away 3x's, so that becomes -7x's minus 3x's, which becomes the same as -7x plus a -3x's. That's how you get your -10x's there. Most commonly, people are going to call that -4x because they see that as a -7 and that as a +3. But this minus sign is changing that to its opposite. Same thing happens here, where you're going to subtract away a -9, which is the same as, oops, let me just show KFC there, which is the same as keeping, flipping, changing, making that plus a +9. Okay, so -7x plus -3x, that gives you your -10x, and then your +9 stays the same. So this is tricky. This is going to take a lot more practice. I feel like this problem, and this problem, you should understand with no trouble at all. This one, I think you can kind of grasp the idea of taking away these from there, but when we start incorporating the taking away from negatives, when there wasn't even a negative or anything there in the first place, that's where it starts to get complicated. And that's where you really have to reflect on your integer rules that we learned way back in chapters 2 and 3 about adding positives, adding negatives, subtracting positives, and subtracting negatives. Okay, here's another example where you've got two piles. So luckily we're adding this pile to this pile. So this is like you're taking 4x squareds and you're going to add to it 2x squareds. And you're going to take an -7x's and add to it 2 -x's. And then you're going to take 3 1s and add to it 5 -1s. Okay, so combining this guy with this guy gives you a total of 6x squared. Combining this guy with this guy, that's a -7x, that's a -2x, is going to give you -9x, or plus a -9x would be fine too. And then the last one to combine would be the 3 and the -5. 3 and -5 is going to give you an answer of -2, or you could say plus a -2. Okay, so something to keep in mind. The only way you can rearrange these terms is if you're adding them all together. The only way to add them all together is to change some of these subtraction problems by using KFC to addition problems and add the opposite. So in essence, what is happening here is every time you see a minus sign, that is the sign of the term that directly follows it. So that's not positive 2x's, that's negative 2x's, as you saw here. That's not a positive 5, that's a negative 5, as you see here. Okay, so when we go down, let me skip to number 8. We got 2x squared and 1x squared, and then negative 3x squared. So these are 3x squareds. That's a negative 3x squared. These guys are going to make a zero pair and completely cancel out. Then we've got 3x's and 4x's that make your 7x's. And then this 2 doesn't have anyone to combine with, so it's just going to stay exactly how it is. So for problem number 8, these guys combine to make 7x plus 2. All right, if you wanted me to work out any of the others that I did not work out, just let me know. I'd be happy to do that. But I'm going to move on to the second page. Okay. So on the second page, they show you some models here. And it's often a good idea, even though I didn't show it here, to actually write out the expression first and then simplify it using your zero pairs. So this literally says you got 5 ones plus 2 negative ones. 5 plus negative 2 is 3, right? Because when you cancel out all the zero pairs, you're left with 3 positives. Here you literally have 3 x's plus a negative x plus 2 plus 1, 2, 3, negative 4. So take away a zero pair, 3 x's minus 1 x is 2 x's, and then 2 plus a negative 4 gives you negative 2 for your answer. Okay, so starting with the original, write it out, and then simplify. I highly recommend doing that, but those are the correct answers here. All right, now let's take a look at a few of these problems. What we didn't see on the front side were simplifying with zeros too much. And we did a little bit toward the end there, but mostly it was just combining like terms with positive x's and positive 1s and positive x squareds. Well, here we're starting to get into more of the negatives. So if I model 7, this is 2 x's plus a negative 3 or minus 3 plus x plus a positive 1. So when we rearrange these terms and put like terms together, and then you remove the zero pair that is there, that ends up being 3x plus a negative 2 or 3x minus 2. For problem 8, you got 3 negative x's, 2 positive x's, and 4 positive 1s. So when we combine our positives and negatives to form our zero pairs, those go away, leaving you with just 1 negative x and 4 positives being added together. Okay? So with that as our process, we look through here and we say, all right, we got an x squared. Are there any other x squareds? Nope, we're going to keep that guy. Now we've got 2 negative x's and 3 positive x's. So you got 1 more positive x than the negative x's. So your answer is going to be positive 1x. And then we've got 3 1s and 1 negative, or yeah, 3 and a negative 1, which combine to make positive 2. So this final answer, after you combine like terms and you remove the zeros, is x squared plus x plus 2. Now let's do a distributive property type of problem. Do I have enough here to? Yeah, I do. Let's do this guy right there. Problem number 12. So we're going to take an x. Let me borrow from these guys. Plus 3, and then you got 2 negative x's there, right? Well, one thing to be aware of here is when you're doing distributive property, you only deal with this multiplier and what's inside the parentheses. So that negative 2x has nothing to do with the distributive property. This is saying take an x plus 3 and repeat it 3 times. So how many total x's are there? 3 x's and 3 3's means we got 3 x's plus 9 plus 2 negative x's. So I'm going to zero out those 2 zero pairs. Oops. Move these guys over here. And what do we have left? You got 1x, there's your x, and your 9 1s to make 9. So x plus 9 is the final answer. So take a look at the rest of those. If you have any questions about how to get the correct answers, please contact me. Otherwise, I'm going to assume that you are understanding this or you see your mistake and you're able to fix your mistake. Okay, so let's move on to our next activity, which I believe should be Chapter 4, Test number 2. Take care. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling blessed,